we have three tables. We are trying to find the function that can represent each table. We know already that we have linear functions, quadratic functions, and exponential functions. And the first thing that you need to think of, which one of these three different functions can be used to represent each one of these tables. Let's take a look at the first table. Looking at the first table, we have the y values, and going from one y value to the next, I am adding 3 every single time. And it's the same number again and again and again. That tells me that this function is a linear function. And we know that linear functions have the formula y equals mx plus b. That means I need to find the slope and I need to find the y-intercept. The slope I already have, which is 3. And the y-intercept, as you can see, is 2 because it's the y value when x equals 0. Looking at the second table, I can see that going from one y value to the next, I am multiplying by 2. And we know that when you multiply to go from one y value to the next, or when you divide, that means you have an exponential function. And the formula for an exponential function is y equals a times b to the x, where a is the initial value, and the initial value in this case is when x equals 0, which is 1. That's a. And b in this case is the factor, which is 2. So the equation is y equals 1 times 2 to the x. Now looking at the third table, we can see that we have a rainbow values. So I have 3 and 3, 6 and 6, and I have 1, 2 in the middle. 1, 2 is the vertex. That means I have a quadratic function. And since I have the vertex, I can write the equation in the vertex form. And remember, this is a possible equation. That means I'm going to use the formula y equals a times x minus h plus k, where a, h, and k is the vertex, h and k. That means the possible equation is going to be y equals a times x minus 1 plus